So problems on safe stopping sight distance or stopping sight distance. In the previous class I've taught you the theory part, and in this class the stopping sight distance and overtaking sight distance, intermediate sight distance, the problems I'll be solving. As I've told you, if you refer the previous video, you will be knowing the formulas whichever is applied. And in the previous class I've told you if V is in kilometer per hour or if V is in meter per second, what formula should be to be applied. So calculate the safe stopping sight distance for a design speed of 60 km per hour for a two-way traffic on a single lane road. The reaction time of the driver is 2.5 seconds. So V is in kilometer per hour. This is a formula to be used, 0.278. V speed is given 60 km per hour. T is taken as 2.5. V and F is taken as 0.35. For the safe stopping sight distance, coefficient of friction for a longitudinal friction is taken as 0.35 as assumption. So for calculate 82.19 meter. For a single lane road, it is 2 times the stopping sight distance. So if the question they've asked for a two-way, for a double lane road, it is 82.19 itself. Because they've asked for a single lane, it is 2 times the stopping sight distance, so 164.39. So calculate the safe stopping sight distance for the descending gradient of 3%. Descending gradient is nothing but they have given you the slope. Descending gradient for a design speed of 80 km per hour, take coefficient of friction as 0.35 and total reaction time of the driver as 2 seconds. So this is a formula. If there is a slope, f plus or minus 0.01 n. Since it is a descending gradient, take minus sign. 0.27, v is 80, t is 2, 80 square 254, 0.35 minus 0.01, n is 3 and 123 is the answer. Next, the ruling design speed on a curve is 100 km per hour and the super elevation on the curve is 7%. Calculate the ruling design radius, take coefficient of friction as 0.15. E plus F is equal to V square by 127R. E is given super elevation, F friction, V speed, R radius is not known, so calculate R. Suppose if they ask you to calculate the grade compensation, 30 plus R divided by R is the radius, calculate this, or 75 by R, calculate this, whichever is the minimum, that is known as a grade compensation. And in one of the questions they have asked you what is right of way. Right of way is nothing but see, this is your carriage way width where the vehicles is carried, and the shoulder width. Shoulder width is given if the vehicle is punctured or any other mechanical damage of the vehicle, and road margins, that is known as the right of way. Next, calculate the design rate of super elevation on a highway in a plain terrain if design speed of the highway is 80 km per hour and radius of the curve is 400. So they are used to calculate the super elevation. So there are 3 conditions. One is I have assumed f is equal to 0.15 and f is equal to 0 and maximum E is taken as 0.07. So by substituting this E, f I have considered this side. So 80 square is a V, 127 R. F I've taken is this side, 0.15. It is negative, so negative cannot be the answer. And if f is taken as 0, same formula apply. E is equal to 0.127 and E is equal to 0.07. So which is the minimum value? So in these 3, the minimum value is 0.07 or 7%. If the stopping distance and average length of vehicle are 18 meter and 6 meter respectively, then the theoretical maximum capacity vehicles per hour of a traffic lane at a speed of 10 meter per second. This question is for traffic engineering topic. So anyway, I'll tell you, stopping sight distance is 18 meter, length of the vehicle is 6 meter, V is 10 meter per second. So based on space headway, S is equal to 0.2 V plus L or stopping sight distance plus L. Whichever need to calculate this, substitute the values. Maximum of this 24 is taken. C is equal to 1000 V by S, or N is equal to 1000 V by S is a formula. V is the speed, S is the space headway, C is the capacity. So 1500 vehicles per hour. So what is the psychological widening of a pavement on a horizontal curve of radius 230 meter for ruling speed? This is the psychological widening formula. Widening of the road psychologically, V divided by 9.5 root of r. What is the psychological valuing? Again, this is a traffic engineering question. So v is 80 km per hour, 9.5, root of r is 230. So this is the answer. Next, calculate the capacity of the road. Same question, capacity of the road. So n is equal to 1000 v by s. Yes, there are two conditions. Take the maximum value, substitute this value. This is the formula to calculate the stopping side distance, because stopping side distance value is not given here. So stopping side distance value you need to calculate by using this formula. Since v is in kilometer per hour, stopping side distance, this is the formula. Substitute, you get the maximum value. N is equal to 1000 v by s. N or c is the n or c, both are the same thing. So these are all the given values. E plus f is equal to v square by 127r. Substitute this. If you take it as so it is you get some answer, convert it in the form of slope. And they have asked you to calculate the length of transition curve. Length of transition curve is equal to EWN. E is nothing but the super elevation 1 in 15. W is nothing but the road width 10. N is the rate of change of super elevation is 1 in 120, or N is only 120. That's 80 meter. Next, a summit curve is formed at the intersection of 3% up gradient. So usually the formula is n1 minus n2. Since n1 is taken as up gradient 3% and 5% down gradient, usually the formula is n is equal to n1 minus n2. Okay, so n1 is taken as up gradient, so it is 3%, minus n2. n2 is taken as 5% down gradient, so it is minus 5. So 3 minus into minus is plus 5. So 3 plus 5 is 8. Since they have asked you to calculate the length of the summit curve, so it is ns squared by 4.4. This you forget, ns squared by 4.4. Substitute, you get 298 meter. A vehicle was stopped. This is the average skid resistance formula. F is equal to 2s by gt square. 2 into s is nothing but 9.8 skid marks. G is 9.8 into 2 square is 0.5. Next, for a circular curve of radius 200 meter, coefficient of lateral friction 0.15, design speed is 40 km per hour, equilibrium superposition for equal pressure on inner and outer wheel. For suppose for inner and outer wheel, F is equal to 0, E is equal to V square by 187R, you get 6.3. And same thing, if they have given you headlight distance, this is a formula. Ns square by 4.4, you have calculated in the previous. If they have given you headlight side distance, Ns square by 1.5 plus 0.035, yes. N, to calculate N, descending gradient is nothing but minus 1 divided by descending gradient N is equals to minus 1 divided by 25, and since the descending gradient meets an ascending gradient, that is minus, plus ascending gradient is how much? 1 divided by 40. So minus 1 divided by 25 plus into minus is minus 1 divided by 40. So it is 0.0 minus in the negative one you get, forget the negative value, 0.065. N is 0.065. Yes, headlight side distance I given you 100 meter. So S is equal to 100. Substitute, you get 130 meter. Next, an ascending gradient of 1 in 100 meets a descending gradient of 1 in 50. Calculate N. They have asked you to calculate overtaking side distance. Overtaking side distance is taken as 1 is squared by 9.6. So this is the formula. Substitute, calculate the overtaking side distance. Next, brake is applied on a vehicle which then skids a distance of 16 meters before coming to stop. If the developed average coefficient of friction between the tires and the pavement is 0.4, then the speed of the vehicle before skidding is. So V is equal to root of 2G Fs. All the values are given. Substitute, you get in terms of 11.2 meter per second. So the values on the options, if it is in terms of kilometer per hour, convert this into kilometer per hour. So camber for ruling gradient is taken as 1 in 30. So next thing is, there are some questions, fill in the blanks questions. So super elevation is not provided on a horizontal curve of highway, then on which portion of the road or potholes likely to develop is at the outer edge of the road there is a potholes. So full amount of super elevation on a horizontal curve is provided at the end of the transition curve. The speed of a vehicle negotiating a curve is proportional to 1 divided by root of weight of the vehicle. An ideal horizontal transition curve is clothoid spiral. So the transition property of a lemniscate curve is taken with a 60-degree. Ratio between the adopted centrifugal ratio for roads and railways is 2:1. A super elevation is provided on a circular horizontal curve such that the vehicle can be stopped on the curve without sliding. Assuming a design speed v, maximum coefficient of side friction is E is less than or equal to F max friction. So length of summit curve on a two-lane, two-way highway depends upon required overtaking side distance. A vehicle negotiates that is allowable jerk with a radius and J jerk, and minimum length of transition curve is taken as VQ by RG. Width of carriage for single lane road is 3.75. On sag, the available side distance is determined based on nighttime driving conditions. So maximum allowable grades are lower for railways than for highways because steel wheels on steel rails have lower frictional coefficient than rubber tires on pavements. Ideal form of summit curve is parabolic. At highway stretches where overtaking side distance cannot be provided, it's necessary to incorporate at least twice the stopping side distance. So transition curve is provided in horizontal element to facilitate the application of super elevation. The convexity provided in the carriageway between the crown and edge of pavement is known as camber. Superior to the road, gentler is the camber. The distance traveled by a moving vehicle during perception time and brake reaction time is known as a lag distance. So whatever I have done in the geometric design elements in the second part of the highway engineering, these are the main topics which are asked in the previous exams like IES, SSC and all the government state board exams. So only those topics I have covered. Okay, thank you. In the next class I will be solving the problems, that is the question, multiple choice questions which are asked in the previous questions exam with the MCQs. Thank you.